Hey Math 30-2 and welcome to lesson 2.2, introducing permutations and factorial notation. All right, so let's get started. So number one says a common occurrence in the field of math is the successive multiplication of decreasing numbers. For example, suppose the bank issues a new debit card and insists every customer have a 10-digit passcode with no repeating numbers. No repeating numbers is kind of key there. How many different passcodes are possible? So if we kind of thought, if we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that would be like how many digits there actually were on the debit card. So number one says, how many numbers can you choose from for the first digit? So like right here. Well, there would be 10, right? 0 to 9, all those different digits, which there's 10 of them, right? So there'd be 10. Once this number is picked, how many choices do you have for the second digit? So for this one, after you choose one number, you're only going to have 9 left. So there's 9 different options there. And then 8. So 8 for the third. And then you can kind of see where this is going. 7 for the fourth. And so on. So write this string of this string starting from 10, work down to 1 below with a multiplication sign between each number and calculate. So what we really have here is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right, so that's, if you multiplied these all together, that's how many possible debit cards you could possibly have. This, multiplying 10 and then, by 1 down every time, this is called 10 factorial. And that's what that explanation point means. That means factorial. So, yeah. If you have a TI 83 or a TI 84, then here's how you would get to that factorial symbol. You go to math, probability, and then number 4 is the factorial sign. So you type in 10 and then do this. If you have a TI Inspire, what you would do is you could type in 10, and then you can see down in the bottom right of your calculator down here. Hopefully you can see that. It's red now, yeah. You get a few different options. One is right there. So factorial, and then enter, and it's 3,628,800. So a lot of different ways to make debit cards, right, where it wouldn't repeat numbers. So the other way to get to that from your calculator, though, I'll just show you here. If you go to menu, you got a bunch of stuff in here too. So just kind of remember that you have these things. We're in the probability unit, and you can see that we've got, in the probability, there's factorials, and what we're going to be using permutation and combinations here soon too, but factorials is the first one there too. So you can also get to it from there. Okay, number 2, I'm going to let you guys do most of these, but what I'm going to just kind of look at is some of these different situations. So 2.5 factorial. Would that exist? Could you have 2.5 factorial? What would that look like? So remember, our 3 factorial would look like this. 3 times 2 times 1. What would 2.5 factorial look like? Two spots and then like half of a spot. It doesn't really work, right? That doesn't actually make any sense. So try putting that into your calculator. It'll say undefined or something along those lines. Yeah, because you can't have decimal numbers of factorials now. So we're dealing with whole numbers so far. The other thing, -3 factorial. So in brackets there, -3. If you try to put in with the brackets in your calculator, -3 factorial, same thing, you're going to get an undefined message. Because what does a negative number, that's like having, so 3 factorial would look like this, right? 3 times 2 times 1. -3, that would be like having like negative spaces, like these little spots that we can actually have here. It wouldn't make any sense. It doesn't make sense to have a negative factorial. But just as a little caution here, if you had -3 factorial without the brackets, you should end up getting -6 for an answer there. And the reason for that is because this is really saying this is saying 3 factorial, which is 6, and then tacking on the negative after, right? So that's not really -3 factorial. That's 3 factorial with a negative on it after. So hopefully you kind of were able to see the difference there. Try putting this one in your calculator too. See what you get. It might be another one of those situations. And then the last one I wanted to show was 0 factorial. So in this one, we've got 0 factorial. 0 factorial, if you just kind of, so let's kind of work our way down. If I had 3 factorial, what that would be is 3 times 2 times 1. So that's, 6, right? So there'd be 6. What we're saying here is that there's 6 different ways that you could align these things, right? There's no repeating numbers in these spots. There's 6 different like codes that you can make. You can think about it that way too, if it was like combination lock or something. If it was 2 factorial, so 2 factorial is 2 spots, so that's 2 times 1. There's only 2 ways to arrange that, right? So that'd be an easy lock to pick. Next one down, if you had 1 factorial, that means there's only 1 spot, right? So there's just 1. There's only 1 way to arrange that. There's only 1, right? There's just that. And then last, the final thing here is 0 factorial. 0 factorial, think about it as that there's no spot at all, right? There's nothing at all. There's nothing. So but I'm going to say right now, 0 factorial is equal to 1. Why would 0 factorial be equal to 1? Well, what we're saying here is that there are 0 spots, so for this one up here, there was like 1 spot, right? There was like, 1 way to arrange 1. The question is, how many ways are there to arrange nothing? Well, there's 1 way to arrange nothing. There's only 1 way. So that's kind of how this comes about. There's like 1 way to arrange nothing. So you can remember that, which it's kind of neat to think about. If not, just remember 0 factorial is actually also equal to 1. So this is really saying 5 factorial over 1. All right, moving on. Okay, so we're going to be able to write factorials in a few different ways that kind of suit our purposes here soon. So one way would be to just write this 12 factorial as 12 times 11 times 10 times 9, and then dot, 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 3 times 2 times 1. So you're just kind of like writing a dot, dot, dot for the stuff in the middle, just so we don't have to write out everything. And then we could also write it as 12, and then times 12 minus 1. This is 11, right? So we're just writing it a different way. And then 12 minus 2, 12 minus 3, dot, 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 12 minus 10, 12 minus 11. So we could do it like that too, right? And then you could also write it as 10 plus 2, which is 12, 10 plus 1, which is 11, 10, which is 10, 10 minus 1, which is 9, and dot, dot, dot. You can kind of see the pattern happening there, right? So what I want you guys to do is write out 8 factorial 3 different ways. So it'll be, similar to up here, but there's many different answers. So just you guys can choose what you want to add or subtract to make that up. Okay, number 4 says completely expand 12 factorial over 8 factorial and then cancel as much as you can. So that I'm going to write the top and the bottom in different colors here. So I'll write the top, so 12 factorial as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right. And at the bottom, I'm going to write this in green maybe. I'm going to write this as, so 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, so what I mean by canceling now is you can see that we've got a bunch of stuff on the top that's similar to stuff on the bottom. So 1 would cancel with 1. Well, it would just equal 1, so it's just kind of, yeah. And then 2 divided by 2 is that cancels. 3 and 3, 4 and 4, 5 and 5, 6 and 6, 7 and 7, 8 and 8. So what we're really left with here is 12 times 11 times 10 times 9. Okay, and then you can go in your calculator and you go 12 times 11 times 10 times 9. So 11,880. All right, so that'd be your answer for that. So you can kind of see how this would work, right? All right, so now, number 5 here, we're going to get into how to write out this factorial notation when we don't know what the number is. So it's just, we're going to call it n. So the way we're going to do this is you'd start out, you'd say n factorial is going to be equal to, well, we start with n, right? Whatever that number is. And then times n minus 1. So whatever the number is minus 1 will be the next thing you multiply by. The next one would be n minus 2. And then instead of writing this all out for infinity or forever, what we're going to do is go dot, dot, dot. And then the end here, I know that the last things that have to come is going to be 3 times 2 times 1, right? That's always the case. It's always 3 times 2 times 1 at the end. That's the end of your factorial sequence. So this is the general way that you can write out n factorial. Okay, so now number 6 here says expand n plus 2 factorial. Well, that's just going to be, so n plus 2 factorial. You start out with the whatever the factorial was, so n plus 2. And then just the next one is 1 less than that. So 1 less than n plus 2 is n plus 1. 1 less than that is n. And then, maybe I'll do one more too. N minus 1 would be the next one. And then you just go dot, dot, dot. And then I know it's going to end at 3 times 2 times 1. That has to be where it ends. So that would be the expanded version of this when you don't know what the number is. All right, so number 7 says simplify this. So let's write out, I'm just going to write this out over here so we have a lot of room. So we've got n plus 3 times n plus 2. And I'll write this in a different color because we'll take the factorial of n plus 1 now. So that's going to be n plus 1. We're just really doing exactly what we had up here, right? So n plus 1, and then the next one would be n. The one after that would be n minus 1. And then dot, 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 3 times 2 times 1. So it says simplify this now. So how can you simplify this? Well, simplifying this is really just recognizing that this pattern now starts at n plus 3, right? N plus 3 and then n plus 2, n plus 1. This whole thing altogether is really n plus 3 factorial, right? We've just added on to our pattern there. So n plus 3 factorial would be the simplified version of this now. Okay, now B. Okay, so if we expand the top here, we're going to have n plus 1, and then the next one down would be n minus 1, dot, 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 3 times 2 times 1. And this is all over, like a different color. Now in this one, we're going to start at n minus 1, and then that will go down to n minus 2, and then dot, 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 3 times 2 times 1. Well, you can see on the top here, we've got n minus 1 and n minus 1. This is really the same thing, right? Up top here in the green, n minus 1. The next one would be n minus 2, and then down to 3 times 2 times 1. So everything on the top from here on cancels with everything on the bottom from there on. So what we're left with is n plus 1 times n. If you expand that n into that one, this would just end up as n squared plus n. All right, last one. So it says solve. Now that's different, right? The other ones are all simplify. Now we're solving. So we're saying that this is equal to a number. So we're going to be able to figure out what n actually is. We're not going to do the guess and check method. Let's just skip right to the algebraic just for the sake of time. And this is probably what you would do on a test or when you're doing these questions would be the algebraic method too. So, all right, so solving, right off the bat, I don't like the fact that these have factorial signs on them because how do I make that equal to 90? I want to end up with some expression for n is equal to 90 without the factorials. So what I need to do first is expand everything and cancel what I can. So let's expand the tops. We've got n factorial. So I'm going to write that as n times n minus 1 times n minus 2 dot, 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 3 times 2 times 1. So that's n factorial, right? The bottom is going to be n minus 2 and then times n minus 3 and then dot, 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 3 times 2 times 1. And you can see now that everything from n minus 2 on this way is going to cancel with everything from n minus 2 on this way, right? So those all cancel, and what we're left with there is just n times n minus 1. Oh yeah, and this was all equal to 90 the whole time. So that's equal to 90. Okay, now we just need to solve for this. So what I'm going to do is expand this n. So this would just be n squared minus n is equal to 90. And then how do you solve those again? Hopefully you remember from last year. I've got an n squared term and an n term. So this isn't one of those ones that I can just get all the letters over to one side and all the numbers to the other. What I need to do here is factor. So I'm going to bring 90 over to the left side. So I'm going to subtract 90 from both sides. So we've got n squared minus n minus 90 is equal to 0. This is one of those, right, where we made it equal to 0. And now we're going to factor it. So I'm just going to bring it up here for some more room. So we've got n squared minus n minus 90 is equal to 0. All right, we need to factor this. So it's going to be n there and an n there. And I know that this number that's going to go there and this one, they need to multiply the 90 and they need to add to 1. Or multiply the negative 90 and add to negative 1, really. So what about 9 and 10? Those seem reasonable to me. And they need to multiply the negative 90, so one's got to be negative, one's got to be positive. Adding to negative 1, this one's got to be the negative, and this one has to be the positive, right? Negative 10 plus 9 gives you negative 1. Okay, and that's all equal to 0. Now, looking at this, what's n equal to? Well, we're saying, okay, what does this term, or this factor, I should say, need to be to make it equal to 0? Well, n in this case would need to be equal to positive 10, right? So if n was positive 10, so 10 minus 10, that would equal to 0. That would check out. That would make the right side equal to 0 up here, like we have. So n is equal to 10. And then this one, n would need to be equal to negative 9. So those are our two answers so far, but with these ones, what we're going to find is that we need to check them because this might not necessarily be true. So let's check. So let's write over here, check. So I'm just going to write the original expression again. So that was n factorial over n minus 2 factorial is equal to 90. So now what we got to do is just throw these two numbers into here to see if it actually works out. So let's do 10 first. So if I went 10 factorial over 10 minus 2 factorial, that's supposed to equal 90. Let's just keep working our way down now to see if it does equal 90. So 10 factorial up top over 8 factorial is equal to 90, is what it's saying. I'm going to write this out just a little bit different again. This 10 factorial, I'm going to write this out as 10 times 9 times 8 factorial. And then that's all going to be over 8 factorial, and that's equal to 90. And you can see now, if I cross out 8 factorial with 8 factorial, I'm left with 10 times 9 is equal to 90. That's true. So far, n is equal to 10. That is an answer. But let's look at our next one. So n minus 9. Or n is equal to negative 9, I mean. So we've got negative 9 factorial. And make sure you have the brackets because that's different than not having the brackets like we talked about before, right? So we're saying the factorial of negative 9 over, and then negative 9 minus 2 is negative 11 factorial. And that's supposed to be equal to 90. Well, if you try to put that in your calculator, even if you just try to throw this in, it's going to say undefined because you can't have a factorial of a negative number, right? So this isn't going to work. So this is a big X. Doesn't work at all. So this one doesn't work. So we'd say in the end here that n is equal to 10 and circle your answer, please, so I know which one you're talking about. That is the answer. Okay, so that's it for that video. Make sure you guys do the assignment questions, and I'll see you in the next video.